You might have solved equations like this at GCSE, and now that we've seen the graphs, hopefully you can see that actually that was just the beginning of the picture for solving equations like this. So what we're going to do is look at how you would solve a question like this at A level. And there are 5 steps that you need to go through every single time. And I really recommend that you do these 5 things because as the questions get more and more tricky, or they have more and more bits added into them, it's really important that you're going through all of these stages to make sure that you are correct. But we're going to start with a nice simple case. And the first thing we need to do is to check what type of mode we are in. So having a little look at this is our interval, gives us a massive clue as to whether we're in degrees or radians. Now, because this is in terms of pi, 0 to 2 pi, and not, you know, minus 180 to 180, something, you know, in the hundreds of degrees, we know that we are in radians. And so before you've even done anything else, my advice would be to get your calculator in the right mode. It's soul destroying for me and the people it happens to when you walk out of an exam and go, I didn't change my calculator. So do it first. Make sure it's the first thing you're checking for. A second thing to check on your interval, and this won't make sense until we start looking at these more, but make sure that the angle inside the trig function, so here's sine of x, matches with this expression. So if it were a 4x, you'd have 4x in your interval, and if you don't, you need to get it there. We're going to come on to one of those questions in a minute in this video, so I'll show you a little bit more what I mean at that point. Now we can find out our first solution to x by doing exactly what you would have done at GCSE, which is to use the inverse sine button on your calculator. Now, I'm not going to write it as sine to the minus 1 because that notation can be quite confusing. I'm going to use another way of writing it, which is arc sine, but it's exactly the same thing. It just means the inverse sine. Popping that in your calculator, you will get pi over 3, which is 60 degrees. And at GCSE, that's where you would have stopped. But this is just your principal solution. So it's the solution that's closest to 0. We need to find all of the solutions in the interval 0 to 2 pi. So the first thing we should do is have a look at what sine looks like in the interval 0 to 2 pi. And we sketched these in the last video. But that's sine between 0 and 2 pi, so there's pi, there's 2 pi. 0, of course, is our origin point over here. And we're asking, where does it cross the line y equals root 3 over 2? That's what this is. This is y equals sine x. And we're asking, where does it cross y equals root 3 over 2? So root 3 over 2 is like 0.86 something. So it's, oh, that's not a very straight line, but you get the idea. It's some point along there. So here's the first place it crosses. This is the one closest to 0. So here's our pi by 3. We now need to find this value. I mentioned in the last video that the symmetry of these graphs is quite important, and sine has a line of symmetry at pi by 2. We're going to use this to help us figure out what the question mark is. So based on that symmetry, we can see that the gap between the origin point and this first solution, this first place the curve and the line cross, is a gap of pi by 3. We've gone from 0 to pi by 3, so it's a gap of pi by 3. Think about where that mirrors, and that gap is repeated. It's the same distance just over here, in between pi and the solution that I'm interested in. And hence, my question mark is pi, take away pi by 3. We're going backwards from pi, the amount of pi by 3. And hence the two places on the interval 0 to 2 pi where sine of x is equal to or crosses root 3 over 2 are the pi by 3 I found originally, that's my primary solution, and 2 pi by 3, a second solution. And that's it. On that interval, those are the two places where the curve y equals sine x crosses with the line y equals root 3 over 2. Some of it is something familiar from GCSE, but these additional solutions is new. So let's have a look at another one of these. So the first thing we're doing is checking. We are in radians in this case, and we're in the radians in the last one. So hopefully your calculator is in the right mode. We now need to check our angles. Now, in this question, I've got tan of 2x, and I only have a single x in my interval, which is exactly how a question would be presented to you in an exam. Now, this 2x in tan represents a graph transformation. It's a stretch of scale factor half, which means that your tan graph is going to occupy half of the space it used to, and because it keeps going forever and ever, it means that essentially you're going to get double the amount of tan in the interval than you would have normally. Now, I don't mind graph transformations, but they're not my favourite topic, so I don't want to have to think about graph transformations every time I do trig. The trick, the tip, if you like, is to change your interval instead. So what we need to do is make the x's in my interval match the x's in my function, i.e. I need to multiply my entire interval by 2. So 0 times by 2, that's still 0. The x multiplied by 2, that's 2x. And my top interval becomes 4. So instead of having to think about the graph transformation, I'm just going to search over double the interval. And that's quite nice. The other thing I'm going to do is I'm going to essentially, for a while at least, ignore the fact that this is anything other than just single angle, so like just a single x. I have a whole thing about balloons and when one should pop a balloon during a party. Don't be the person who stamps on the balloons midway through, other people are enjoying them. But at the end of a party you might pack your balloons down. Silly little thing, but basically you can't break into that balloon yet. You just have to treat it like it's another letter. So if it helps you to write it as tan theta or tan y, then go for it. But I'm going to work with the 2x. I'm just going to do it. So we need to find our first solution. This is the bit that you would have done at GCSE. So 2x is, now we're going to use our tan to the minus 1, our inverse tan button. But again, I'm not going to use that notation when I write it down. I'm going to use this new one, arctan. It means exactly the same thing, but as I said before, the notation tan to the minus 1 is a little tricky, so we're going to use arctan instead. That gives me a solution to 2x of minus pi by 4. I am not touching that 2x, and here's where that idea of a balloon is a bit easier. I'm not popping it. I'm not midway through the party, that is this trig equation, going to pop that balloon. I'm going to leave it as 2x until the very, very end. Okay, so we've got our first solution, which is the solution closest to 0. I now need to know how many other solutions there are on my new interval. So the point about changing this is that I didn't have to think about graph transformations, but I now have to sketch tan up to 4 pi. So there's pi, 1.5 pi, 2 pi. Carrying on, 3 pi, 4 pi. And we're asking, where does this graph, this tan graph, intersect with the line y equals minus 1? So it's going to be somewhere here. There's y equals minus 1. Now, the calculator told me that the first place, or the place closest to 0 where that happens, is minus pi by 4. I can't currently see that on my graph. That's over here in the left-hand side of your graph. So I can actually just extend. I'm not interested in the solutions there, but it's useful for me because I can highlight where it is. So this is my minus pi by 4, the thing that's closest to 0 that gives me that first solution. The next one, the first one I'm actually interested in, is over here. And then there's another one that's here, a third one here, and a fourth one here. Now pi, because it doesn't have lines of symmetry, actually I think ends up being one of the nicer ones to solve. We just need to add pi every time, because this is the same place on the graph every single time. And we know that the graph repeats every pi radians, it's its period. So I just need to add pi. So this is minus pi over 4 plus pi. This is the minus pi over 4 plus 2 pi, because it's the previous one plus pi again. And then this one, 3 pi, because we're adding pi again. And then 4 pi again, because we're adding pi again. So my solutions to 2x is, where are they? Minus pi by 4, which I'm not going to be interested in, but I'll leave it there because it was the first solution my calculator gave me. The next one is 3 pi by 4. Then I have 7 pi by 4, 11 pi by 4, and 15 pi by 4. At this point, and this point alone, when I can do nothing else, I have reached the end of my wonderfully engaging trig party. And now I can pop my balloons. I'm not someone going around spoiling other people's fun. It's the end of the day, everyone's gone home and the balloons can go away. Essentially what that means, when you're not going to take my silly joke for it, is that only at the end should we be dividing by 2, or whatever it is that you've got wrapped around this angle. So now and only now will I find x. It's minus pi by 8, 3 pi by 8, 7 pi by 8, 11 pi by 8, and 15 pi by 8. And I can just cross out that first solution because that one is out of my interval. I'm only interested in solutions between 4 pi, 0 and 4 pi. And now back in x, only solutions between 0 and 2 pi, which all 4 of those fit into. So how difficult can these types of questions get? Well, here's a particularly involved one, should we say. There's a lot more going on in my angle, but the process is exactly the same. There is actually one other difference with this question, and that is that coefficient of 2. Every other question you have done, of which there may only have been a few, have a coefficient of 1 there. It's just sine of stuff equals a number, cos of stuff equals a number. So we need to get rid of that first. It's nice and easy, we're just going to divide by 2. Now it doesn't affect my angle, that's sine of that angle, it can't get touched there, but I can turn the right hand side into a half. Now it's looking a little bit more like the types of questions we've seen before, except for my angle, so my balloon, if you will, is quite a monster here, but that's okay, we can cope. So checking my interval, I'm in radians, I've been there a while, so hopefully I won't need to change my calculator. And now I need to make the angle, the x, match the angle, this big old thing here, from my question. So the first thing I'm going to do to get there is multiply by 3, so that would be 0 still, and then 3x, and strictly less than 3 pi over 2. And now I'll minus pi by 6. So the first one would be minus pi by 6, 3x minus pi by 6, and the top end there is 4 pi by 3. Now they match, I can go on just like normal and start to solve this question. So the first thing I'm going to do is undo the sign from the left-hand side of that expression by using arcsine. So I'm working out arcsine of a half, and that's pi by 6. Now don't forget, I have a balloon around that angle, so I can't go breaking into it yet. I have to wait until I finish my entire question. So my next job is to go and find all of the solutions to where sine x equals 1 half in between 4/3 of pi down to minus pi by 6. So here's my minus pi by 6. I can't quite finish my trig graph on the end there because I don't quite get up to 2 pi, but 4/3 pi is somewhere around here. The graph would of course continue on. It doesn't have to be perfect, just as long as you're making sure that you've got enough solutions in. And don't forget, the whole point of doing it that way was that I could still sketch the normal sine graph. I didn't have to think about graph transformations. I don't want to have to think about the graph transformations of sine of 3x minus pi by 6. I really don't. Much nicer to be able to sketch sine and just sketch a different amount of it each time. So we're asking, where does this graph cross the line y equals a half? So I'll draw that half line in. And the first solution is this one here. That's our pi by 6. Here's pi, so I definitely need this next solution, which is just backwards off of it. Again, using that line of symmetry that we had, This gap here, which is a gap from 0 to pi by 6, so it's a distance of pi by 6, matches, is mirrored by this gap over here. So this point is pi minus pi by 6. Going much further beyond in either direction, and my sine graph isn't crossing the line y equals a half anymore, so I don't actually need to worry about any other solutions. So the solutions I've got to my balloon, 3x minus pi by 6, are pi by 6 and 5 pi by 6. I don't need any other solutions, so I've reached the end of my trig party that I've been having with myself, and I can now go about the process of popping that balloon, so actually finding out what x is from those equations. So really we're solving these like little linear equations. So I've got the first one, which is 3x minus pi by 6 equaling pi by 6. So I'd add the pi by 6 on, which gives me pi by 3, and then divide, which is pi by 9. I've also got that 3x minus pi by 6 equals 5 pi by 6. So again, adding on the pi by 6 gives me a pi, and then dividing by 3 gives me pi by 3. And there are my two solutions. The last thing to tell you about is how to check these on the calculator. And if you have a CG50 or CG20, so one of the big graphical calculators, you're in luck. There is a button that will help you solve this stuff. If you have seen any of the other stuff that I've done, or you're in one of my classes, you will know about this button already. In the normal run menu, if you click on the option button and then select the option for calc, which is on the big calculators, it's on F4. You can then use the solve n button, which is on F5. Type in your equation, so your original one, 2 sine 3x minus pi by 6 equals 1. Then hit the execute button. It will give up a message saying there are infinitely many solutions. That's absolutely true. We know that. This graph goes on forever. And you'll get listed about 10 solutions, most of the ones around the middle going out from either side. So at that point, you can just select on that answer line and scroll through and find the solutions that you're interested in and just check that they're correct. Now they're going to come out as decimals, and nearly always these questions will be asked for exact values. So you're going to leave your answers in terms of pi, but you can check the decimal equivalents using the solve n button on your calculator.